Settle in and let the room get a little quieter around you. Picture a late-night laboratory where the air smells faintly of solvent, warm dust, and tired metal. You think the danger would look dramatic or glow politely in a corner like a movie prop. It does not. It hides in powders, in fingerprints, and in the soft click of instruments that never raise their voice. Tonight, you drift through the ordinary routines of a Manhattan Project uranium chemist. Labels, logbooks, slow evaporation, careful hands. The Sleepless Scientist stays with you, not to wake you up, but to make the science feel gentle and human. Because most world-changing work arrives quietly, as a smudge of color, a tiny weight difference, and one more calm note in the book. You are already at the bench, because the ward does not care if you are sleepy. You stand under a lamp that makes everything look slightly older than it is. Your first job is not discovery. Your first job is inventory. You check a bottle's label, then check it again, because labels are what keep mistakes from spreading. You write in a logbook with the careful patience of someone defusing a bomb, using cursive. You think the important moments will feel cinematic. They will not. They will feel like waiting for a beaker to stop steaming. They will feel like watching a meniscus settle and realizing you were wrong by a hair. A late shift has a particular sound. It is mostly silence, interrupted by glass touching glass. Somewhere a fan pushes air through ducts, as if the building is trying to breathe for you. There is no heroic music. There is only the soft complaint of a balance when you ask it to tell the truth. Your hands move through a routine that has been repeated so often it has become a kind of spell. Rinse, dry, tear the balance, weigh the paper, add the powder, weigh again, write it down. And if you have the wrong number, you do it again with the same calm face. Because panic is a contaminant. The strange thing about wartime science is how much of it is boring. It is not boring in the way a lecture is boring. It is boring in the way a lock is boring. Until you remember what it is locking. You spend minutes, sometimes hours, just waiting for things to change slowly. A solution clears, a precipitate forms, a gentle cloud in liquid. A filter clogs because nature has its own opinions. And through it all, your body tries to forget what your mind cannot. You work with checklists because the brain is not reliable at 2 in the morning. You work with checklists because the brain lies when it is tired. It tells you that you already washed your hands. It tells you that you already capped that bottle. It tells you that a tiny spill is not a big deal. So you do not trust it. You trust paper. You trust the quiet tyranny of procedure. The danger most nights is not a dramatic accident. The danger is that nothing dramatic happens, so you start to feel safe. The danger is that the lab looks like any other lab. There is glassware and paper and a ring stand with a clamp. There are stains on the counter that no one can identify anymore. There are tired people with tired jokes. And there is a material that will change the politics of the planet sitting in a jar like flour. You learn quickly that the job is mostly not touching things, not touching your face, not touching your pen to your mouth, not touching the outside of a glove with bare skin. You become a person who notices hands, your hands, other people's hands, the way fingertips hover, then decide, then retreat. you start to understand that science is not only thinking, it is handling. And handling is a moral act when the substance in your care does not forgive. The easiest way to picture your night is to imagine a long sequence of small, careful movements. You lift a stopper and you keep it in your palm so it does not roll. You pour a liquid slowly down a glass rod so it does not splash. You swirl a flask with a patient wrist like you are coaxing an answer out of tea. You watch droplets gather at the edge of a pipette. You let them fall one by one, counting quietly. You might be tempted to feel important, but the lab does not reward ego. It rewards repetition. You learn to treat every jar like it contains the same lesson. This is not about what you meant to do. This is about what you did, what you wrote, and what you can prove later. Even the way you label things is part of the survival. Name, date, batch number, mass, your initials. Sometimes a coded note that only the right eyes can interpret. Because secrecy is another chemical in the room. And it is in everything. It is in the way you lower your voice when someone walks past. It is in the way you do not ask certain questions out loud. It is in the way you explain your work to your family as if you are describing a boring job, which is not entirely a lie. Secrecy makes the world smaller. It turns your life into a series of rooms. And tonight, your room is this bench, and this light, and this steady patience. And once the room feels familiar, you start noticing the strange star of the whole operation. Uranium, a metal that looks boring until you remember what it can become. You do not meet uranium as a glowing green rock. That is the story people tell later because people like their danger to be colorful. You meet uranium as something dense and dull. It has the visual charisma of old coins. If you hold a chunk of it, it does not feel magical. It feels like responsibility. It feels heavier than it should for its size, as if gravity is slightly stronger around it. That is the first truth uranium teaches you. Heavy. Not poetic heavy, but physical heavy. Uranium is dense, meaning you can fit a lot of mass into a small volume. A small container suddenly has the weight of a serious mistake. You learn to grip jars with both hands. You learn to set them down gently. You learn that dropping one is not only embarrassing. Dropping one is paperwork, alarms, cleanup, and the slow dread of wondering where the dust went. But most nights, you are not holding a shiny metal chunk. Most nights, you are dealing with compounds, salts, oxides, powders that range from pale yellow to tan like dried mustard, solutions that look like weak tea or old urine or the last inch of a cheap beer. That is another truth uranium teaches you. The apocalypse at the bench often looks like a stain. Uranium chemistry is full of states that feel domestic. Dissolve, heat gently, cool, filter, wash, dry, weigh. You might do all of that just to learn that your yield is a little low. A little low means you did something wrong, or the material started wrong, or the universe simply refused to cooperate, so you do it again. Not because you love repetition, because you love correctness more than you love sleep. You learn the vocabulary because vocabulary is how you control fear. Uranium often appears in the lab as the uranyl ion, spelled like a small, polite monster. It is uranium with oxygen attached, carrying a charge, and it likes to form salts. In human terms, it means the uranium has a habit of traveling in water in a particular costume. That costume is yellowish, and it stains glass in a way that makes you squint. The uranyl ion can bind with other ions to make crystals, powders, and precipitates. And those forms are practical. They are easy to weigh, easy to store, easy to move through a process. Easy also to spill. When you work with uranium, tiny amounts matter. Not because tiny amounts will instantly kill you. Most of the time, they will not. Tiny amounts matter because the project is built out of tiny differences. Tiny differences in purity. Tiny differences in composition. Tiny differences in how much of one isotope is present compared to another. And contamination is easier than perfection. Contamination happens when your sleeve brushes a surface, when a stopper touches the counter, then touches the flask, when a scoop that should be clean is not. Contamination is not evil. It is lazy physics. Particles like to travel. They like to hitch rides on shoes, on cuffs, on the oil of your skin. They like to become part of the room. So you become a person who respects small things. You respect dust. You respect droplets. You respect the dark little flakes that appear when a solution dries on a surface, because it is never just dirt anymore. It is information. It is cost. It is risk. The romantic story of science is a person having a brilliant idea. The real story, in a lab like this, is a person preventing 1,000 small disasters. You do not feel like a wizard. You feel like a careful janitor of matter, and you are. Your day or your night is built from glassware and notes and patience. And in the middle of it, you keep circling the same quiet problem. Uranium chemistry is not just chemistry. It is chemistry with rules, and the rules are written by radiation. Radiation is an invisible house guest. It does not knock. It does not announce itself. It does not care if you are a good person. You cannot smell it. You cannot taste it. You cannot feel it. At least not in the moment when it matters. Your body does not have a sensor for it, the way it has sensors for heat and pain. So the lab builds a nervous system out of machines. You wear a badge on your chest, like a silent report card. It might be a film badge, a small piece of photographic film that darkens if radiation hits it. In human terms, it is a camera that never takes a picture of anything you want. It only takes pictures of what went through you. Sometimes there are pocket dosimeters, little devices that can be read more often. Sometimes there are survey meters, the handheld instruments that tell you what the air will not, and they make a sound, a click or a faster click. Or, if you are unlucky, a rough buzzing that feels like a reprimand. The clicking is strangely calming. It turns fear into a rhythm. It turns invisible risk into something countable. It tells you softly that something is happening even if your skin insists everything is fine. You learn quickly that radiation is not one thing. It is a category of things like weather. There is alpha radiation, which is heavy and easily stopped, but cruel if it gets inside you. There is beta radiation, lighter and more penetrating, like a rude finger poking through layers. There is gamma radiation, which is the one people imagine, the deep, penetrating kind that passes through you as if you are only a suggestion. In the lab, the kind of risk you worry about depends on the form of the material. A solid chunk that stays a solid chunk is one kind of worry. A powder that can become airborne is another. A solution that can splash or dry into a residue is another. And the truly irritating part is that the most dangerous thing can look the most ordinary. A smear, a grain, a dusting so thin you do not see it until you see it everywhere. So safety becomes a soft ritual. Distance, shielding, time, simple ideas repeated until they feel like prayer. Distance means you keep your body away, using tongs when you can. It means you do not lean over an open container like you are smelling soup. Shielding means you put dense material between you and the source. Lead, concrete, even water in some contexts, because it slows and absorbs. Time means you do not linger. You do the work, then you leave. Not because you are lazy, because exposure is cumulative, and the bill comes due later. You learn that the lab coat is not armor. It is a flag. It says, "This person is in the zone. Do not hug them. Do not let them sit on your couch." Gloves are not magic either. They tear, they get pinholes. They transfer contamination if you touch the wrong thing. So, gloves become part of the mindfulness. You notice them. You change them. You keep your hands away from your face because your face is a collection of openings, and nature loves openings. The anxiety comes from what you cannot sense. There is no smell to warn you, no heat shimmer, no bitterness on the tongue. Your body does not flinch in time. So, you listen to instruments instead. And you listen to rules. And you listen to the older chemist who tells you, quietly, that the dust is the enemy. Dust is how trouble travels. Dust is portable. Dust is persistent. Dust is what gets into the cracks of your nails, and into the weave of cloth, and into the corners where brooms do not reach. Dust is why housekeeping in a uranium lab is not an afterthought. It is part of the experiment. The lab learns to treat every surface like it can tell on you later. Benches are wiped. Floors are mopped with more care than most people give their kitchens. Ventilation matters because the room is not just a room. It is a flow system. Air comes in, air goes out, and whatever is in the air goes somewhere. So the lab is designed to keep air moving in predictable ways. Fume hoods pull air away from your face, swallowing vapors and particles. Filters trap what they can. Ducts carry the rest away to places you do not see. You are grateful, but not too grateful, because ventilation is also a reminder that you are not alone with your work. The building is part of it. The town is part of it. The world is part of it eventually. You do not think about that too hard on a night shift. You think about the beaker in front of you. You think about the balance. You think about the logbook entry you need to make. But dust has a way of making itself the main character. And speaking of dust, nothing makes you respect housekeeping like learning how easily a harmless-looking powder can turn into your entire problem. Powder is messy by nature. It clings to the inside of a jar because static and humidity have their own small dramas. It floats if you pour it too fast. It settles on sleeves, on papers, on the rim of a container, and then it reappears later where you swear you cleaned. You learn to move differently. Fast movements are for people who have never had to swab a room for contamination. You pour slowly, you tap gently, You keep lids close. You keep labels facing outward because you do not want to rotate a jar too many times. You do not want to handle it more than necessary. Every extra motion is another chance for a tiny mistake. A good chemist becomes a quiet choreographer. Your elbows stay close. Your hands work at bench height, not up near your face. Your attention stays on the mouth of the container, the lip of the funnel, the edge of the paper. You do not talk with your hands. You do not gesture over open samples. You do not laugh too hard while you are transferring powder, because laughter makes air move. It makes your chest bounce. It makes your hands less steady. Congratulations! You have discovered that joy is a contamination hazard. Spills are not dramatic. They are quiet, procedural, and followed by long cleaning that feels like penance. A small puff of powder lands on the bench. There is no explosion. There is no alarm unless the instrument notices later. There is only your brain, suddenly awake, doing a cold inventory of what just happened. You stop. You freeze your hands where they are. You do not swipe at it because swiping turns a spill into a cloud. You do not blow because you enjoy breathing. You reach for damp wipes because moisture keeps particles from becoming airborne. You contain. You fold the wipe inward so the contamination stays inside. You bag it. You label the waste because even the trash has to be accounted for. And then, after the spill is gone, you clean again, because the first cleaning is for the visible problem. The second cleaning is for the invisible one. The third cleaning is for your conscience. The worst habit in the lab is absent-mindedness. Scratching your nose, rubbing an eye, licking a finger to turn a page. Your mouth is worse. It is warm, wet, and full of soft tissue that absorbs whatever you gift it. A finger to the lip is not a habit here. It is a delivery method. You learn this the same way you learn most lab rules, through quiet embarrassment and loud consequences. Someone, somewhere, did the wrong absent-minded thing once. Now you live inside the paperwork fossil of that mistake, so you train yourself like a small animal. Hands stay low. Hands stay visible. Hands stay busy. If you need to itch your nose, you do it with the back of a clean wrist. After you have stepped away, if you need to turn a page, you do it with a clean tool. Or you accept that you will fumble. You stop treating your body like a friend in the room. Your body is a liability with opinions and saliva, and you are paid, in a loose sense, to keep your liabilities under control. The lab has tiny rules that sound silly until you picture the alternative. No food, no gum, no cigarettes, even though the 1940s loved cigarettes like oxygen. No touching doorknobs with your gloves. No leaning on the bench, even when your spine begs for it. You become a person who can hold still without looking tense, because tense people make fast movements. Fast movements make air move. Air movement makes dust move. And dust is the whole story, wearing a cheap costume. You notice how powder behaves like a living thing. It creeps toward edges. It hides in the threads of cloth. It waits in the seam between tile and wall, like a patient little landlord. You do not chase it with dry paper, because that just teaches it to fly. You pin it down with damp wipes, with careful folding, with a slow hand that never slaps. You learn to clean like a person removing fingerprints from a crime scene. Small strokes, fresh wipes, waist folded inward, always inward, like you are trapping a secret. Then you bag the waste. Then you label the waste. Then you place it where waste goes, which is never just the trash, because this lab does not have trash. It has categories of future problems: dry waste, wet waste, sharps, contaminated glass, contaminated paper. Everything has a container, and every container has its own handwriting. Sometimes the most exhausting part is not the chemistry. It is the constant proof that you were careful. Proof is a ritual. Proof is how you sleep later, when your bed is far away from the bench. If the lab has an altar, it is the sink. Not a magical sink, just a metal basin and harsh soap under too bright light. But you wash like your life is composed of your fingerprints, because it is. You wash before you leave a hood. You wash after you change gloves. You wash after you touch anything that touched anything else. You wash because skin has tiny valleys, and powder loves valleys. You scrub under nails because nails are small shelves. You rinse until the water runs clean, which is a comforting lie, because clean is not visible here. Clean is measured. Clean is confirmed. Clean is a reading on a device. Later, when someone swabs your bench and counts, that is the strange comfort of a lab like this. You do not have to trust your feelings. Feelings are inaccurate instruments. You get machines instead, and machines do not care about your pride. Once your hands are disciplined, your attention drifts toward the humming helpers. The instruments sit on benches like small animals, each with its own nervous little voice. There is the balance, which judges you in milligrams and silence. There is the hot plate, which pretends to be simple while it burns solutions into crust. There is the fume hood, which sounds like a constant wind you cannot turn off. And then there are the counters, the clicking counters, the devices that translate invisible particles into an audible complaint. You pick up a survey meter, and it has a weight that feels official. A handle, a face with numbers, a needle that trembles as if it is shy. Sometimes it is a Geiger counter, the kind people will later recognize from films. A tube inside, filled with gas, waiting to be disturbed. Radiation passes through, knocks electrons loose, and the tube responds with a pulse. In human terms, it is a doorbell that rings when something you cannot see walks through the room. Each click is a single event, not a dramatic event, just a tiny ionization inside a tube, a microscopic shove. But the sound gives you something your body cannot, a sense of weather. Slow clicking means light drizzle. Fast clicking means the roof is leaking. Right over your bed, you learn that instruments have moods. Some click happily at background radiation, the normal faint hiss of the universe. Cosmic rays from space, natural radioactivity from rocks, from concrete, from the world itself. Other times, the clicking changes when you bring the probe near a sample. It grows faster. The needle climbs. The device does not panic, because it cannot. It just reports. You become attached to that honesty, because people in a war project are not always allowed to be honest. Calibration becomes its own bedtime story, repeated until you can recite it. You check the device with a known source, a little standard that says, if your counter reads this, you are sane. If it reads higher, you are scared. If it reads lower, you are even more scared, because broken safety tools are the cruelest joke. You adjust, you record, you sign. The logbook fills with numbers that seem dull, until you remember each one is a slice of time you survived. Most of your measurements are not heroic discoveries. They are comparisons. This sample versus that sample. This reading today versus yesterday. This filter paper now versus before. The whole lab runs on differences so small you could lose them in a sneeze. That is why you double check. That is why someone else checks your work, not because they distrust you. Because the material does not care who you are. The material only cares what you did. If you ever hear tension in the room, it is not from excitement. It is from uncertainty. Uncertainty is the only true enemy in measurement. So you fight it with routine. Count for the same length of time. Hold the probe the same distance. Use the same geometry, the same arrangement, because the device responds to position. Radiation spreads like light, and your distance matters. Too close, and you saturate the detector. Too far, and you convince yourself the problem is smaller than it is. You learn to respect the inverse square law without naming it. Move the detector away, and the intensity drops fast, like gossip losing energy down a hallway. This makes distance feel like a physical tool in your belt. A step back is not laziness. A step back is shielding made of air. Even your body becomes part of the experiment. If you stand between the source and the detector, the reading changes. You are made of water, and water absorbs and scatters. Congratulations, you are now part of the apparatus. You keep your posture consistent. You keep your breathing quiet. You let the counter click like rain, and you write down the count. Then you subtract background. Background is the universe reminding you it is never truly quiet. There is always some decay somewhere. Some atom somewhere is changing its mind, breaking apart, and throwing off particles. Even when you are doing nothing, time is doing chemistry. That is the calm cruelty of radioactive decay. It does not need permission. It does not need light. It just happens on schedule that no one can negotiate. The lab tries to tame that schedule into something usable. Half-life is the term. It sounds gentle, like a nap. It means the time it takes for half of the unstable atoms to decay. In human terms, it is a deadline you never asked for, that the atoms always meet. Uranium has a long half-life, which is why it sits around like an ancient nuisance. But some of its decay products do not wait. They decay faster, and that creates a family of radioactivity that can complicate your readings. Your sample is not always just the thing you think it is. It can be a little household of daughters and grandchildren, each emitting its own signature. Sometimes you measure alpha activity. Alpha particles are heavy, 2 protons and 2 neutrons, like a tiny cannonball. They do not travel far in air. A sheet of paper can stop them, and that is why alpha feels deceptively safe. But if alpha-emitting material gets into your lungs, it is close enough to matter. Then the cannonball hits living cells over and over in one small spot. That is the kind of damage that makes the future complicated. Beta particles are lighter. They travel farther. They can penetrate skin a bit, and they can be stopped by plastic or thin metal. Gamma rays are the ones that slide through you, indifferent, like a cold draft through a cracked window. Gamma demands dense shielding, lead, concrete, distance, and the stubborn refusal to linger. In the Manhattan Project labs, much of the obsession is with controlling what gets inside you. Internal exposure, inhalation, ingestion, tiny particles that lodge in lung tissue or settle in bone because the body mistakes them for familiar minerals. It is one thing to stand near a source for a short time. It is another to carry the source in your ribs. So you treat your own mouth like a restricted area. You treat your lungs like a sacred space. Your nose becomes suspicious. Your throat becomes a question. If you taste metal in the air, you do not trust it. You trust the instruments instead. You trust the swabs, the filters, the ventilation that drags the air away from your face. And still, the lab keeps finding new ways to surprise you with how ordinary risk can look. Because the counter is not just for samples. It is for doorknobs, for sleeves, for shoes, for the floor where someone walked after stepping in something they did not see. You can sweep the room with the probe, slow arcs, like you are searching for ghosts. And in a way, you are. Not supernatural ghosts, just the invisible leftovers of decays, the little emissions that say, something has been here. Sometimes you find a hot spot, a corner of a bench that clicks faster than the rest, a smudge you cannot see, but the instrument can. You mark it, you clean it, you measure again, and you learn that cleanliness is iterative, not a state, but a process. The way the instrument clicks becomes familiar enough that you can hear when it changes. A steady tick, tick, tick is normal. A sudden chatter is a problem. A loud burst is a story that will have a report attached. You listen like a person listening to a distant engine for signs it is about to fail. Machines, at least, do not hide their discomfort. People do. People in this project are tired. They are secretive. They are proud and frightened and sometimes bored out of their skulls. And because everyone is exhausted, the human side leaks in through the cracks. Coffee is everywhere, even though it is not supposed to be near the work. It arrives in mugs with chips on the rim, held too close to lab coats. It smells burnt because the pot has been on too long. The coffee is not good. It is not meant to be good. It is meant to be a lever, prying your eyelids open. You drink it and feel your stomach complain. You drink it anyway. Sleep, in this world, is a resource like uranium, limited, controlled, accounted for by schedules and supervisors and the quiet reality of war. Secrecy adds a special loneliness. You cannot tell people what you do. Not really. You can say you work in a lab. You can say you handle chemicals. You can say you are contributing, but you cannot say the words that would make it make sense. So your life outside work becomes a play with missing dialogue. Someone asks how your day was, and you give them weather. Someone asks what you are working on, and you give them a vague shape. You get good at vague. Vague becomes a second language. Inside the lab, you do not have to be vague, but you still have to be careful. Rooms have access rules. Badges open some doors and not others. Information is compartmentalized, a word that makes knowledge sound like a shipping crate. You learn not to ask questions that cross boundaries. Not because you do not want to know, because you do not want to be the reason someone looks at you differently. And yet, people still bond. Because humans bond in any enclosure. Night shift has its own small family. The same faces, the same tired smiles, a shared sense of being awake when the rest of the world is dreaming. Jokes are quieter at night, not because humor is forbidden, but because the building feels like it is listening. Someone makes a joke about glowing in the dark. Someone else rolls their eyes because uranium is not that kind of glow. Someone makes a joke about turning into a superhero. Another person, older, does not laugh because they have seen what radiation sickness actually looks like. Gallows humor is not cruelty. It is pressure relief, a way to acknowledge fear without letting it sit on your chest. You learn the small rituals people use to feel human. A favorite pencil sharpened the same way every shift. A particular spot on the bench that is considered yours. A habit of lining up glassware in neat rows like soldiers. A habit of wiping the same surface twice, not because it needs it, but because you need it. Routine is a sedative, and the lab hands it out for free. The background pressure to be useful never fully leaves. Even when the work is slow, you feel the urgency like a low-frequency hum. The war is not in this room, but it is in the calendar. Deadlines, shipments, reports. The sense that somewhere else, other people are doing their own exhausting part, and you are a link in a chain you cannot see. Sometimes news comes in fragments. A new process is working better. A shipment was delayed. A test result was promising. But the biggest truth is that most nights feel like waiting for a precipitation to complete, waiting for a solution to cool, waiting for a filter to stop dripping, waiting for the counter to finish counting, waiting for dawn, because dawn means shift change, and shift change means you can stop pretending you are not tired. In the middle of that waiting, you still have ordinary needs. Your hands get dry from washing. Your eyes sting from staring at glass lines and tiny handwriting. Your shoulders knot from holding them still. Your stomach asks for food at inappropriate times. But food is complicated here because of contamination. So you eat in designated areas if you eat. You drink water from designated fountains. You keep your coat out of those areas like a dirty secret. You learn to separate your life into clean and not clean. The boundary follows you. It becomes mental. It becomes moral. And that pressure to be correct, to be clean, to be careful, leads you into the heart of the daily grind. Not the dramatic physics, not the cinematic moment, the slow puzzle of separating nearly identical things and pretending it is simple. Because the hardest part of uranium in this story is that it comes in flavors that behave almost the same. Isotopes, same element, different weight. Same chemistry, different nuclear personality. They sit in the same beaker and laugh at your desire to sort them. Uranium-238 and uranium-235, two siblings who wear the same clothes and refuse to sit in separate chairs. Chemically, they are almost indistinguishable. They form the same salts. They dissolve the same way. They precipitate the same way. So, if you are hoping to separate them with ordinary chemistry, the universe gives you a patient smile. You can do it, but not easily, and not with one clever trick. It becomes industrial patience. It becomes process. At the bench, your part may not be isotope separation itself. which often happens in massive facilities with machines the size of buildings. But you live in the world created by that problem. Purification, conversion from one compound to another, removal of impurities that would interfere with later steps, careful accounting of yields, because every gram matters. And because the mission is sorting, your life becomes a long sequence of almost the same steps. It is like doing laundry with two shirts that look identical in dim light. You hold one up, squint, decide it is slightly different, and hope you are not lying to yourself. Evaporate, filter, rinse, dry, measure, write, then do it again. Sometimes you are producing uranium oxide, a powder that looks like dull yellow or brown depending on its form. Oxide sounds simple, like rust. In human terms, it is uranium combined with oxygen, stable enough to handle, still dangerous enough to respect. Other times, you are dealing with uranium salts, uranyl nitrate for example, which dissolves readily, a crystalline solid that can look almost pretty in a depressing way. Pretty like frost on a window if the frost could poison your future. There may be steps to convert uranium into uranium tetrafluoride, a greenish solid sometimes called green salt. It is not a friendly green. It is a chemical green, the kind that says, "Do not breathe me." Fluorine chemistry is its own nightmare because fluorine is aggressively reactive. Hydrofluoric acid, if it is involved, I'm sorry, but I cannot assist with that request. It touches glass and leaves a ghostly etch, like a rude autograph you cannot scrub away. It touches skin and pretends, at first, that nothing happened. Then it sinks in, literally, and starts arguing with your calcium. In human terms, some of these chemicals do not just burn you. They recruit your body chemistry and make you participate in the damage. So you learn to treat certain bottles like they are full of patience tax, not because they explode, because they demand perfect attention every single time. You keep caps tight, you keep labels readable, you keep secondary containers under everything, like you expect betrayal, and you keep a strange respect for materials that do not look threatening. A dull powder, a clear liquid, a pale green salt. No warning colors from nature, no bright stripes, just quiet compounds waiting for you to be sloppy. The separation work makes you humble like that, because the whole project is humility disguised as industry. You are not inventing uranium into something new. You are just nudging it through forms that behave better, soluble when you need to move it, insoluble when you need to catch it, crystalline when you need to weigh it, dry when you need to ship it. Every step is a compromise between chemistry and hands. A wet cake on a filter is chemistry. A wet cake that has to be scraped off without splashing is hands. You stand there, watching the last droplets fall, and you realize this is your life, waiting for gravity to do its slow work through paper fibers, listening to a fan, writing down times and temperatures, and feeling, faintly, the pressure of being a tiny human in a big machine. Because the machine does not love drama. It loves throughput. It loves repeatability. And repeatability is a kind of boredom you earn. If you do it right, nothing happens. Nothing exciting. Nothing memorable. Just the same safe motions. One more night. One more entry. That is the rhythm you live inside. Measure, adjust, record, then send the material onward, like passing a sealed letter you are not allowed to read. somewhere else, in a different building. Different people do their own version of this. They run columns and cascades and furnaces. They fight impurities and leaks and schedules. And they are all solving the same annoying puzzle. How do you separate things that nature made almost identical? How do you convince siblings to live in different houses? The answer, most of the time, is not brilliance. It is persistence. 1,000 small steps that each barely help. A factory built out of patience and powered by fear. And at the end of your shift, you might not feel like a scientist. You might feel like a person who spent 8 hours negotiating with paperwork. You check your bench one last time. You wipe it again, even if it looks clean. You sweep the counter with the detector probe, slow and careful, clicking steady, clicking normal. You log the waste. You cap the bottles. You close the hood sash to its marked line, because even air has rules here. Then you do the last ritual, the one that follows you out the door. You check yourself. Sleeves, gloves, shoes. The detector passes over you like a bored inspector, and you hope the sound stays boring. Because boring means you get to go home without a new story. And the older you get, the less you want new stories from this place. The pressure to be correct does not stop at the bench. It follows you into the hallway, into the locker room, where coats hang like tired skins, into the sink, where you wash again, because washing is the one action that feels like control. You change clothes because you want a boundary between work and life. Not a perfect boundary, just one you can pretend is real. Then you step outside, and the air is cold, or damp, or dusty, depending on where this lab sits. And for a moment, the world looks normal. Streetlights, a quiet road, the sound of your own shoes. But your mind does not fully leave the building, because you have been learning night after night that the most powerful forces are the ones you cannot feel. And once you learn that, it is hard to unlearn. You start noticing risk everywhere, even in ordinary life. A stove flame, a speeding car, a frayed wire, invisible hazards, dressed up as routine. And that thought, as dark as it sounds, is also oddly comforting. Because it means you have been living with invisibility your whole life. You just did not have a clicking instrument to narrate it. Speaking of invisible forces that behave like rules written into the universe, you cannot spend long nights around uranium without eventually thinking about what makes it special. Not the yellow solutions, not the heavy jars, the nucleus, the cramped little center of the atom, where most of the mass sits like a grudge. You have been taught in school that atoms are tiny solar systems, electrons orbiting, nucleus like a sun. It is a sweet metaphor. It is also wrong in the way fairy tales are wrong. Electrons do not orbit like planets. They live in probability clouds, more like a fog of where they might be. And the nucleus is not a neat ball of calm. It is a pile of protons and neutrons pressed together by forces you cannot see. It is stable until it is not. In uranium, the nucleus is too large, too crowded, too ambitious. It is a heavy family living in a small apartment. Everyone is touching, everyone is irritated. And every so often, someone leaves. Radioactive decay is that leaving. A nucleus changes because the arrangement is not sustainable forever. It throws off an alpha particle, or a beta particle, or a gamma ray, not out of malice, out of physics, out of the simple truth that some arrangements are temporary. Uranium decays slowly over timescales that laugh at human calendars. But the reason the Manhattan Project cares about uranium is not just that it decays, it is that certain uranium nuclei can be split. Fission, a word that sounds like a small tear. It is a violent kind of breakup, a nucleus snapping into smaller pieces, and when it snaps, it releases energy, because the starting arrangement had tension stored inside it. Not tension like feelings, tension like a compressed spring hidden inside matter. You do not see the spring when you hold the jar, you just feel the weight. But the spring is there, in the numbers the physicists whisper about. Binding energy, mass defect, words that mean some of the mass is missing because it became energy. In human terms, the atom has been paying a mortgage in pure potential. Fission is foreclosure. The bank vault opens and everything inside gets thrown into the street as heat and radiation. The comforting part, if you can call it that, is that the energy mostly becomes heat, plain heat, the kind that boils water, the kind that warms metal, the kind that makes steam push a turbine, because even the strangest physics ends up doing chores. This is the gentle detour you take. Standing in your quiet lab, what is nuclear energy really? It is not a green glow. It is not a mystical power. It is a different way of getting heat from a different kind of fuel. Instead of breaking chemical bonds, like burning coal or gasoline, you break nuclei. Chemical energy is like rearranging furniture in a room. Nuclear energy is like tearing down a wall. Both release energy. One is just more committed. And the reason a chain reaction matters is because one split nucleus can cause others to split. Neutrons are the messengers. A uranium nucleus splits and it throws out neutrons like shrapnel. Those neutrons can hit other nuclei and persuade them to split too. Not with logic, with impact. So you build a situation where one event leads to more than one event, and more than one leads to more than one. That is the chain. In human terms, it is gossip that makes more gossip. A rumor that causes 3 rumors, each of which causes 3 more. It grows fast, and then it grows faster. The hard part is controlling it. A controlled chain reaction is a reactor. An uncontrolled one is a weapon. The difference is not in the atom. The difference is in the engineering and the timing and the willingness to accept what comes next. Even in a reactor, the goal is almost boring. Make heat at a steady rate. Boil water, spin machinery, generate electricity, or run experiments, or produce materials. The universe gives you a dragon, and you use it to turn a wheel. But the dragon wants to run away. So you use moderators, materials that slow neutrons down. You use control rods, materials that absorb neutrons, like a sponge absorbs spills. You adjust. You monitor. You keep the reaction at the level you can live with. You do all of this because nature does not do middle settings without help. Nature does slow decay. Nature does runaway chain reactions if conditions allow. Nature does not do convenient human outputs. So you force convenience with metal and math and exhausted chemists. It is strange to think that all your careful bench work is upstream of this. Your rinsing and filtering, your weighing and labeling, your boring entries in a logbook, all of it exists because someone needs the material to be pure enough, predictable enough, and in the right form. Because when you are dealing with chain reactions, small impurities become large problems. Neutrons do not care about your intentions. They care about what they collide with. They care about cross-sections, about probabilities of capture and scattering. In human terms, they care about what is in the room with them. So, the project becomes obsessed with purity, with removing elements that drink neutrons, with keeping the material consistent. And your job, night after night, is to make consistency out of a stubborn element. You might not see the reactors. You might not see the bombs. You might not see the final assembly. But you see the first truth of it, the quiet one. World-changing science is built out of clean glass and tired hands. It is built out of people doing the same thing carefully until the future arrives. And because you are human, you cannot help but feel two emotions at once. Because the physics is real, and it is astonishing. Dread, because the application is also real, and it is not astonishing. It is practical, it is efficient, it is the universe's indifference turned into policy. That mix of awe and dread does something to you over time. It teaches you a new relationship with risk. You start thinking in probabilities, even when you do not want to. What are the chances the spill was contained? What are the chances the instrument was calibrated? What are the chances the badge will show something you do not want to see? And then, outside the lab, what are the chances a cough is just a cough? What are the chances fatigue is just fatigue? Risk becomes a lens you cannot easily take off. The body, meanwhile, keeps its own score, not in dramatic ways, most of the time. In quiet ways, dry hands from soap, a crease of tension in your jaw, a soreness between your shoulder blades from leaning forward, careful, for hours, a headache from solvent fumes that still sneak past hoods and rules. You tell yourself you are fine, because most days you are. But the body records anyway. It records sleep debt. It records stress hormones. It records the way your heart rate jumps when the counter clicks too fast. You become intimate with delayed consequences, because radiation is not usually a slap. It is a note slipped under your door to be read later. Sometimes the harm is immediate if exposure is high enough. Burns, acute sickness, a sudden, ugly lesson. But more often, the fear is long-term. Cancer risk, organ damage, changes that take years to become visible. The mind hates that kind of threat. The mind wants fast feedback. Touch fire, feel pain, learn lesson. Radiation does not teach like that. Radiation teaches like bureaucracy, slowly, impersonally, with outcomes that may arrive long after the person who caused them has retired. So you look for control in small, immediate things. You wash your hands with almost religious care. You change your clothes before you go home. You keep your work shoes at work. You check your badge with the quiet hope that it will confirm your story. You keep routines neat because neatness is a kind of spell. Neatness says, I am the kind of person who does not make mistakes. Of course, neat people make mistakes too. They just make them neatly, which is not always an improvement, but the ritual helps. It gives your nervous system something to do besides imagine futures. There is also the moral weight, the one no instrument measures. You may not know the full shape of the project, but you know enough. You know that the material you purify is not for medicine, not for gentle power stations, at least not yet. It is for something final, something designed to end an argument by ending a city, and you are a small part of it. Not a mastermind, not a villain in a film, just a person who filters solutions and labels jars. History is built out of people like that. That is what makes it so depressing. No cape, no obvious moment when you can say, "This is where I became responsible." Just one more shift, one more sample, one more careful step done correctly. You carry that weight quietly because you cannot talk about it. You cannot bring it to dinner. You cannot set it on the table like a dish. So it sits in you, heavy as the metal you handle. And still, life continues in small, stubborn ways. Breakfasts eaten too early. Bus rides with strangers who smell like soap and cigarettes. Letters that say ordinary things because ordinary things keep people sane. Someone laughs at a joke that has nothing to do with atoms. Someone complains about the weather. Someone falls in love, or tries to, because humans do that even when the world is sharpening knives. You find yourself grateful for small normalities. The way a warm mug feels in your hands in a safe room. The way clean clothes feel after you peel off the lab coat. The way your bed feels like a separate universe free of clicking instruments, but the lab does not fully leave you. It leaves habits behind. You stop licking your finger to turn pages. Even years later, you wash your hands longer than other people. You notice dust floating in sunlight, and instead of thinking it is pretty, you think about where it lands. Congratulations, you have been permanently educated. And even if you never see a symptom, the mind keeps replaying scenarios. Did I cap that bottle? Did I touch my face? Did the hood airflow seem weaker tonight? Did the counter click faster near my sleeve? Or was I imagining it? The mind is a terrible supervisor. It works overtime, and it never clocks out. In the Manhattan Project, there were safety programs, monitoring programs, evolving standards. There were health physicists, a new kind of professional, inventing rules while the work raced ahead. There were exposure limits, revised as people learned, and as people guessed. There were mistakes, because there are always mistakes. There were incidents that became memos, and memos that became training. There were people who got lucky. There were people who did not. And the cruelest part is that the outcomes were not always cleanly linked to causes. A person gets sick years later, and the file is thin. A person stays healthy, and the file is also thin. The universe does not provide satisfying narratives. It provides statistics. So, you live in a world where you are told to be careful, and you are. But you are also told, quietly, that certainty is not available. Only risk reduction. Only best practices. Only the hope that your small rituals are enough. That is the atmosphere you breathe, alongside solvent and warm dust and metal. It is not just chemistry. It is a new relationship with the future. A future that feels less like a story and more like a probability distribution. Speaking of probability distributions, there is a smaller, more personal version of this lesson happening inside you right now. Even as you sit here listening, your own cells are doing their own night shift. They are copying, repairing, sorting, filtering. They are running checklists written in proteins and enzymes, and they are doing it in the dark without your permission, because that is what bodies do. Your blood, for example, is a constant transport system. Not heroic, just busy. A river of cells and salts and dissolved gases, moving because your heart is a pump that refuses to take a break. And if you want another cozy cosmic horror thought, your cells are also dealing with radiation. Not Manhattan Project levels, not usually, but background radiation, cosmic rays, natural radioactivity in the ground. Even your own body contains radioactive isotopes, like potassium-40, quietly decaying inside you. You are, in a boring sense, slightly radioactive. Congratulations, it does not matter most of the time because your body has repair systems. DNA gets damaged and enzymes patch it. Cells make mistakes, and other cells notice. Your immune system patrols, looking for the weird and the wrong. It is trench warfare at microscopic scale, fought in warm darkness with no medals. And that is why the Manhattan Project lab feels so unnerving. It is an external version of something your body already fears. Damage you cannot sense, change that arrives later. So your mind learns to respect invisible things because you have always been made of invisible things. And the more you think about it, the more you realize your life is a series of separations too. Your lungs separate oxygen from air. Your kidneys separate waste from blood. Your liver separates toxins from nutrients. Your cells separate useful molecules from noise. Separation work is not just an industrial problem. It is the definition of staying alive. In the lab, you separate isotopes and impurities. In your body, you separate safe from unsafe every second. And the process is not elegant. It is messy, wet, salty, and loud if you listen closely. If you listen closely, your own circulation has a sound not in your ears, but in your imagination. A soft rushing, like distant plumbing in an old building. You are not a thinker tonight. You are a single red blood cell on graveyard shift. You are a flexible disk of hemoglobin, built for squeezing through places you will hate. You think you are drifting in a calm river. Wrong. You are being shoved through elastic tunnels by a heart that does not negotiate. Every beat is a door slam behind you. The walls around you are warm, wet, and alive. They are lined with endothelium, a thin, slick skin that tries to keep things smooth. It mostly succeeds, which is why you get to be bored. Bored is the goal inside a body. When you are not bored, someone is having a very bad night. Your job is simple, in the way war jobs are simple. Pick up oxygen in the lungs, drop it off in tissues that are always hungry. Carry carbon dioxide back, because waste never walks itself out. The oxygen binds to hemoglobin, an iron-holding protein that does not sleep either. Iron, the same element that rusts on a fence, is what lets you carry breath. Congratulations, your life depends on a metal that loves to react. Your hemoglobin changes shape when oxygen binds. It is cooperative, meaning the first oxygen makes the next ones easier. In human terms, you are a bus that opens more doors once the first passenger steps on. You pass through arteries first, high-pressure highways, thick-walled, built to handle the heart's insistence. Then you enter smaller streets, arterioles, where smooth muscle pinches and relaxes. The body is always adjusting traffic, not with signs, with chemistry. Nitric oxide can tell vessels to relax, widening the road. Other signals tell them to tighten, narrowing the road. You feel it as speed, fast in some places, slow in others. Then the capillaries arrive and you finally understand why you were built squishy. Capillaries are narrow enough to force you single file. You fold, you bend, you slide through, rubbing softly against the wall. This is where exchange happens. Oxygen leaves you, diffusing into tissue that has been quietly starving. Diffusion is not heroic. It is molecules wandering downhill, from crowded to less crowded. The tissue is low on oxygen, so oxygen drifts in. The tissue is high on carbon dioxide, so carbon dioxide drifts out. You do not choose any of this. You are a container being used by physics. Carbon dioxide does not just ride back in your fluid. Some of it becomes bicarbonate, a changed form that travels better in water. An enzyme called carbonic anhydrase helps fast and efficient. In human terms, it is a translator who turns a difficult phrase into something the bloodstream can carry. Your blood is buffered, meaning it resists wild swings in acidity. That buffer is one reason you can survive a sprint, or a panic, or a long night awake. But buffers have limits. Push hard enough, and the chemistry starts to show strain. Now picture the lab again, briefly, without fully going back. The chemist watches gauges and counters, trying to keep invisible risks contained. Your body does something similar, constantly. You have sensors for oxygen levels, carbon dioxide levels, and pH. In the brainstem, chemoreceptors listen to the chemistry of your blood like a supervisor with insomnia. If carbon dioxide rises, breathing increases. If oxygen drops, alarms go off in quiet, biological ways. You do not notice most of it because noticing would be exhausting. Instead, you get a feeling later, like air hunger. By then, your internal lab has already been adjusting. For minutes, your red blood cell life is not long by human standards. About 4 months, give or take. No nucleus, no DNA to repair. You are a disposable tool, optimized for a single task. When you get old, your membrane gets less flexible. You start to fail at squeezing through tight spots. Then the spleen notices. The spleen is a quality control office with no patience. It filters blood through narrow passages, and it traps cells that cannot bend, macrophages, immune cells that eat problems, break you down. They recycle your iron. They send your heme to be processed into bilirubin, which ends up in bile. In human terms, you get dismantled for parts, and the body acts like it is being practical. Because it is. There is no sentiment inside a metabolism. Speaking of metabolism, every tissue you pass is burning fuel. Glucose, fatty acids, sometimes other molecules when things get desperate. Mitochondria in cells take oxygen and use it to extract energy from food. They make adenosine triphosphate, the cell's spendable currency. In human terms, it is the paycheck every cell uses to buy survival. The price is waste heat and carbon dioxide. The heat keeps you warm in bed right now. The carbon dioxide is why you exhale. Nothing is free, not even comfort. And now, since you are already inside the body, you can drift to the organ that feels most like a chemist's bench. The liver. You do not see it, but you feel its influence. The liver is a wet factory with 1,000 small assembly lines. It receives blood rich with nutrients from the gut. It also receives blood carrying whatever else came with dinner. The liver decides what to store, what to release, and what to dismantle. It stores glucose as glycogen, a long chain that can be broken later. It modifies fats, packages them, sends them away. It makes proteins for blood clotting because the body is always preparing for injury. And it detoxifies, which is a polite word. Detoxify means it changes chemicals so you can get rid of them. Sometimes it makes them less reactive. Sometimes it makes them more water-soluble. Sometimes it accidentally makes a chemical more dangerous for a while, then fixes that too. A classic example is alcohol. Ethanol becomes acetaldehyde, which is more toxic, then becomes acetate. In human terms, the liver turns a party into a problem, then cleans it up. This is why hangovers feel personal. They are chemistry debts. The liver also handles metals and poisons in ways that would interest any wartime chemist. Heavy metals can bind to proteins and interfere with enzymes. The body responds by locking them up when it can. Metallothioneins, small proteins, can bind metals and reduce damage. It is not perfect. It is triage. Your kidneys take over from there, filtering blood all day and all night. You drift toward them now, again, as a red blood cell, watching the architecture change. The kidney's filtering unit is the nephron. Each kidney holds about 1 million of them, 1 million tiny laboratories running in parallel, quietly judging your bloodstream. Blood enters a tuft of capillaries called the glomerulus. Pressure forces water and small molecules out through a filtration barrier. Cells and big proteins stay behind. Ideally, in human terms, it is a sieve that tries not to make mistakes. The filtrate enters tubules where the real work begins. The body reabsorbs what it wants: glucose, amino acids, sodium, water. It secretes what it does not: hydrogen ions, potassium, certain drugs, and metabolites. It fine-tunes pH and volume and electrolyte balance. This is why dehydration feels awful. It is the kidney trying to stretch your remaining water like a miser. The hormones involved are not gentle. Antidiuretic hormone tells the kidneys to save water. Aldosterone tells them to save sodium. And water follows. The renin-angiotensin system tightens blood vessels to preserve pressure. In human terms, your body becomes stingy and tense when resources feel scarce. Now think back to the lab's obsession with contamination. The body has its own version, and it is less polite. Your immune system treats contamination as an invasion. Not in metaphors, in tactics. A splinter, a virus, a bacterium, a weird cell that looks wrong. The response is layered, like security in a facility that expects sabotage. First, there is the barrier layer: skin, mucus, cilia in the airway that sweep debris upward, stomach acid that dissolves many hopeful pathogens. Then, the innate immune system responds. Fast, general, blunt. Neutrophils arrive quickly, aggressive, and short-lived. They chase chemical signals, squeezing out of blood vessels into tissue. Macrophages sit in tissues like bored guards, then wake up when trouble appears. They eat invaders and present pieces of them, like evidence. Inflammation increases blood flow, making areas warm and red. It makes vessels leaky, allowing immune cells to enter. It also causes swelling and pain because the body is not concerned with comfort. Pain is a notification system, not a kindness. Then, slower. The adaptive immune system ramps up. T cells and B cells, specific recognition, memory. The first time you meet a pathogen, it can be rough. The second time, the response is faster because the body remembers. In human terms, trauma becomes strategy. This is why vaccines work, by giving your immune system a rehearsal without the full disaster. Even here, there is paperwork, just chemical paperwork. Cytokines are the memos. Antibodies are the targeted tools. Major histocompatibility complexes are the display boards. It is all very official for something happening in warm mucus. And all of it is vulnerable to the same enemy the uranium chemist fears. Tiny damage, DNA breaks, misfolded proteins, a cell dividing when it should not. Most of the time, your body catches these. Cells have checkpoints in the cell cycle. Proteins like p53 can stop division when DNA is damaged. It can push a cell into repair mode. If repair fails, it can trigger apoptosis, programmed cell death. Apoptosis is a cell choosing to die for the body's benefit. In human terms, it is the rare moment biology looks almost noble. But it is also ruthless because it has to be. Because if damaged cells keep dividing, they can become cancer. Cancer is not one disease. It is a category of rebellion. Cells that ignore signals grow too much. Avoid death, recruit blood vessels, spread. The immune system sometimes recognizes and destroys early cancers. Sometimes it misses. Sometimes the cancer learns to hide. Congratulations, even your own cells can learn deception. And now, for a moment, let's return to radiation. But keep it gentle. Radiation damage at the DNA level often means ionization. An energetic particle or photon knocks electrons around. It breaks chemical bonds or creates reactive molecules. Water can split into radicals, which then attack DNA. It is indirect sabotage, done by physics. Cells repair single-strand breaks fairly well. Double-strand breaks are harder. Misrepair can create mutations. Mutations can be harmless, harmful, or occasionally useful. Evolution runs on the long ledger of these accidents. Your body tries to keep the ledger balanced in your lifetime. This is why low levels of radiation are a risk, not a certainty. The probability changes, not the immediate sensation. Just like that quiet uranium lab, where danger is mostly statistical until it is not. Now, because you have been patient, you get a delayed payout. You have been thinking of uranium as a chemical nuisance and a nuclear threat, but uranium is also, very mundanely, a heavy metal toxin. Its radiological hazard is one part of the story. Its chemical toxicity is another. Urinal compounds can damage kidneys because kidneys concentrate things. The body filters blood, and toxins can accumulate in tubules. In human terms, the organ that cleans the mess gets exposed to the mess. So, in those wartime labs, chemists had to fear two different kinds of trouble. Radiation, invisible and delayed. Chemistry, corrosive and immediate. And because humans love efficiency, the project used other lovely materials too. Beryllium, used as a neutron reflector and in other components. Beryllium dust is toxic when inhaled, causing chronic beryllium disease, a lung condition where the immune system forms granulomas, little defensive knots. It can feel like slowly losing air over years. Solvents, used for cleaning and processing, could damage nerves and livers. Nitric acid could burn skin and lungs. Hydrofluoric acid could quietly infiltrate tissue and disrupt calcium. Even if you never touched the dramatic core physics, the lab was still a buffet of hazards, which brings you back to a simple fact. The Manhattan Project was not only a physics project, it was a materials project, a chemistry project, an engineering project, and, in the shadows, a human endurance project. Now imagine you are back in that lab, but later in the program. The process has matured. There are more forms to fill, more safety signs, more supervisors who learned what to fear from earlier mistakes. Your day is a sequence of controlled actions, not because control is natural, but because chaos is expensive. And you, personally, are expensive because training a chemist takes time. Wartime programs learn to value humans the way they value equipment, not tenderly, practically. You arrive and sign in. You check your assignment. You gather glassware that is clean, meaning it passed whatever test counts as clean today. You inspect for chips and cracks, because cracked glassware is not just wasteful. Cracked glassware is a future spill with a schedule. You prepare reagents carefully, acids in labeled bottles, bases, salts. You might prepare a standard solution for titration. Titration is a slow ritual where you add one solution to another until a color change signals completion. In human terms, you drip patience into a flask until chemistry says yes. Some uranium analyses used colorimetry. Uranyl ions have characteristic yellow colors in solution. You can compare intensity to standards. It feels crude, but it can be effective. Other methods used gravimetry, precipitating a compound and weighing it. Gravimetry is the ultimate boring method. Turn chemistry into a solid, dry it, weigh it, write it down. The beauty is that the scale does not care about your mood. The cruelty is that neither does the scale. You might also use spectroscopy though. Wartime equipment varied. Spectroscopy is reading how matter absorbs or emits light. In human terms, it is listening to a chemical's accent. For uranium, there are characteristic absorption bands. But remember the era. Many labs relied on methods that were slow but dependable, because when you are making history, you want the boring technique that works. Now, there is a human detail that tends to vanish in clean documentaries: the smell of nitric acid. Sharp, biting, clean in the worst way. The smell of hot metal and steam. The smell of rubber gloves, slightly sweet and stale. The smell of solvent, ether, or acetone, evaporating too fast. Under it all, the smell of tired people who have been working too long. Not dramatic, just real. And you can hear the lab too. The fume hood fan, constant. The clink of glass, the scratch of pen on paper. The occasional cough someone pretends is nothing. The click of a counter, steady as an insect. And somewhere, a phone rings because war projects love phones. Someone answers in a controlled voice. Information moves in fragments, like ions in solution. Now the delayed payout continues. Why did separation dominate this whole effort? Because uranium-235 is rare in natural uranium. Most natural uranium is uranium-238. Only a small fraction is uranium-235. And uranium-235 is the one that readily sustains a fission chain reaction with slow neutrons. That is why enrichment mattered. The chemistry bench was upstream of massive industrial separation methods. Gas diffusion, for example, used uranium hexafluoride gas. It pushed the gas through porous barriers. The lighter molecules with uranium-235 diffused slightly faster than the heavier ones. Slightly. That word does a lot of work. You needed stage after stage after stage, a cascade of barriers. In human terms, it is sorting sand by throwing it through a sieve 1,000 times. Electromagnetic separation used ionized uranium in a magnetic field. Ions with different masses curve differently. It is precise, but slow and energy hungry. In human terms, it is sorting twins by watching how they slide on an icy hill. Thermal diffusion exploited temperature gradients. Centrifuges later would spin gas to separate isotopes by mass. But during the Manhattan Project, the big early workhorses were diffusion and calutrons. And all of these required chemistry to make the right compounds. Uranium hexafluoride, for instance, is a volatile compound. Volatile meaning it becomes a gas at manageable temperatures. That made it usable in diffusion systems. But it is also reactive and corrosive. It reacts with water to produce hydrogen fluoride and other products. So dryness mattered obsessively. Moisture was not just a nuisance. Moisture was an enemy that made the system chew itself. So chemistry had to deliver material in forms that fit the machinery. Oxides converted to fluorides. Fluorides converted to hexafluorides. And every conversion step was an opportunity for loss, contamination, and exposure. The lab becomes a place where the air itself feels like a reagent. Humidity is not weather, it is risk. Now think about the human coping again. When your job is to reduce tiny uncertainties, your brain starts seeking certainty elsewhere. You keep your pencil aligned with the notebook spine. You fold towels the same way. You walk the same route through the building. You drink coffee from the same mug. You sit in the same chair in the break room because the chair feels like control. And yet, outside the lab, you cannot fully relax. You might find yourself checking your hands under light, not because you expect to see contamination, because looking is a ritual that pretends seeing is enough. You might notice small cuts more than before, because skin breaks are entry points. You might notice how often people touch their faces, how often people lick fingers, how often people eat without washing, and you cannot say anything, because then you sound insane. So you keep it to yourself. That is the loneliness of technical knowledge. Once you know how fragile safety is, you see hazards everywhere. Not with panic, with a kind of exhausted clarity. That clarity follows you back into the building because your shift is not done yet. You still have to do the most human part of any dangerous job. You have to prove to another tired person that you did it right. You sign your initials beside a row of numbers, and you feel how flimsy that is. Ink is such a small fence for something that wants to spread. So the lab builds fences out of redundancy. One person prepares the reagent, another person checks the label, a third person verifies the calculation slowly, as if reading a curse, because a misread decimal point is not a mistake here. It is a shipment that goes wrong, a process that drifts, a whole chain pulled offline. You learn to respect the tyranny of units. Milligrams feel like dust until you remember dust is the enemy. Milliliters feel like nothing until you watch a spill crawl into a crack. So you say the units out loud sometimes, under your breath, not as a spell, as a tether. Mass, volume, concentration, time, temperature, and you keep everything written down because memory is not evidence. In a lab like this, your memory is just a soft animal. It startles easily. It runs when the phone rings. It panics when a supervisor appears in the doorway. So you lean on the tools that do not care about your mood. The balance, the timer, the calibrated flask, the burette with its etched marks, patient and unforgiving. You do the slow measurements again, even when you are sure. Not because you doubt your skill, because uranium does not care about your skill. And war does not care about your pride. The funny part is that the most dangerous thing in the room is not always the uranium. Sometimes it is the ordinary chemical that wants to hurry. Nitric acid, for example, does not need a secret clearance. It bites your nose the moment you uncap it. It fizzes when it meets the wrong metal. It stains skin yellow, a strange souvenir of proteins reacting. You can smell it, and that makes it feel honest. Radiation never gives you that courtesy. So chemists learn to fear the obvious things in one way and the invisible things in another. The lab becomes a place where you practice two kinds of attention, the kind for hazards that announce themselves and the kind for hazards that whisper. You can almost feel the two attentions switching in your body. When you handle acid, your muscles stay ready. When you handle radioactive dust, your muscles slow down. Fast is how you splash. Fast is how you inhale. So you become gentle. A slow creature in a fast war. You do not rush the funnel. You do not slap the filter paper flat. You do not shake the jar like a spice bottle. You coax. You persuade. You let gravity do what it does, because gravity is reliable. Then you check your hands again, because hands are where people betray themselves. You glance at your fingernails, and you think about tiny shelves. You think about the way powder likes to sit in corners. You wash again, because washing is the only ritual that feels like forgiveness. And the night keeps moving, because it always does. Not with drama, with paperwork. Somewhere in the building, someone else is doing their own version of this. Maybe they are checking a gasket on a line carrying uranium hexafluoride gas. Maybe they are reading a pressure gauge, listening for the sound of a leak. That gas is a special nightmare. It is uranium in a form that wants to travel as a vapor, useful for separation methods, and very eager to react with water. And water is everywhere, because humans are mostly water. So those systems crave dryness the way a desert craves shade. Seals, desiccants, heaters, pipes kept warm so nothing condenses where it should not. Because if the gas meets moisture, it becomes corrosive products and trouble. The chemistry is simple, in an ugly way. Uranium hexafluoride plus water makes uranyl fluoride and hydrogen fluoride. In human terms, it turns into a solid crust and a chemical that hates your bones. So people learn to fear humidity like it is sabotage. They check dew points. They monitor flow. They tighten bolts with the quiet seriousness of a person sealing a coffin. And if you are a bench chemist, you hear about those problems like rumors. A line went down, a valve seized, a leak was detected. Someone had to suit up and enter a room that smelled wrong. It makes you grateful for your small beakers. Then, of course, you remember your beakers are not harmless either. You are handling uranyl salts that the body does not want. You are making solutions that can splash. You are drying powders that can become airborne. So your gratitude stays small. The lab gives you no safe place to rest your attention. That is why the work changes your posture. Even outside the building, you carry yourself like a person avoiding door frames. And that is why the tired jokes matter. The mug with a ridiculous slogan, the shared complaint about the coffee, the tiny celebration when an analysis matches the expected value. People in a sealed world make meaning out of crumbs because you cannot talk about the larger thing. You cannot say, I am scared of what this becomes. You cannot say, I wonder who will pay for this later. So you talk about the small things you are allowed to touch. The filter paper brand that clogs less. The pen that does not smear on damp gloves. The hot plate that heats evenly. The supervisor who never remembers names. And in those small conversations, you find the only softness available. It is not friendship exactly. It is mutual endurance. Then, the job pushes you into a different kind of endurance. The kind where you wait for results that take time. A film badge will not tell you anything tonight. It will be developed later, in another place, by other hands. In the moment, you carry uncertainty like a second badge under your shirt. Some labs use pocket dosimeters, small devices you can check more often. They can drift, they can be bumped, they can lie a little. So even when you have more immediate feedback, it is still not certainty. It is a hint, a suggestion, a weather report, not a guarantee. And because you are human, you still do what humans do. You search for patterns. You think, I worked near that hot spot for about 10 minutes. You think, I stood behind the shield most of the time. You think, I wore my gloves, I washed, I did everything right. Then you remember how often people do everything right and still lose. Not in melodrama, in statistics. A risk does not promise it will happen. It only promises it is possible. And you can feel your mind trying to bite down on that idea, trying to chew it into certainty. It cannot. So it gnaws quietly. That is the psychological aftereffect of invisible hazards. You keep replaying the night in your head, not because you enjoy it, because the brain treats uncertainty like unfinished business. It wants closure. It wants a clean ending. But radiation and toxins are slow stories. Sometimes the ending arrives years later. Sometimes it never arrives, and you are left with a question mark that feels heavier than any jar. That is why people cling to routine so hard. Routine gives you a small ending every time. You label the bottle. That is finished. You wipe the bench. That is finished. In a project that never feels finished, small finishes are sanity. And still, You are not just a mind. You are a body on a schedule that does not agree with war. Your sleep gets broken into odd pieces. You wake in the afternoon with a strange taste in your mouth. Not from uranium, probably. Just from fatigue and coffee. Your stomach learns to accept food at odd hours. Your skin gets dry from constant washing. You develop little cracks near your knuckles, and you hate them because cracks are entrances. So you use lotion like it is another piece of safety equipment. You learn that safety is not just shielding and distance. It is sleep, too. Sleep is when the body repairs, when hormones reset, when the immune system does its quiet accounting. But the project borrows sleep from you, night after night, and you pay interest. Irritability, fog, a slight tremor when you hold a pipette too long, an ache behind the eyes. And the cruel part is that exhaustion looks like carelessness. So you become exhausted while trying to never appear exhausted. That is a special kind of strain. It makes people older faster. It makes laughter thinner. It makes tempers shorter. And in a lab filled with things that punish haste, that matters. Now, the other after effect is stranger. It is moral, but it does not feel like philosophy. It feels like a quiet pressure in the chest. When you read the newspaper, you see headlines about battles and casualties. You see maps and arrows, and you know your work is tied to those arrows somehow, even if you cannot trace the line. You are making material purer. You are pushing yields higher. You are reducing losses, and the better you are, the closer the project gets to its goal. So you are proud of competence and uneasy about consequence. Those two feelings live together like mismatched roommates. And because you cannot talk about it, you let it settle into habit. Some people cope by refusing to imagine the end point. They focus on the bench and only the bench. They treat the project like a series of chemistry problems with no politics. Other people cope by leaning into the necessity story. They tell themselves that the enemy would do it too. They tell themselves that speed saves lives in the long run. Maybe it does. Maybe it does not. The universe does not grade your intentions, it grades your outcomes. And outcomes in this era are harsh. That is part of why this story feels like cozy cosmic horror, not because there are monsters, because humans can build monsters out of paperwork and metal, and still the days keep coming, because time is indifferent. You keep going to work, you keep washing your hands, you keep writing in logbooks, you keep listening to the gentle scolding of instruments, and then, eventually, the project ends. Or at least, the particular frantic chapter ends. The buildings do not vanish. The techniques do not vanish. And your body does not reset to factory settings. You leave with habits you cannot unlearn. You leave with a relationship to dust that will never be innocent again. You leave with a private little library of smells that make your stomach tighten. Hot acid, old solvent, warm metal. You leave with a sense of how thin the membrane is between safe and unsafe. Most people live their whole lives without thinking about membranes. You have spent years working inside them. Now, since you have drifted into the body already, it is worth staying there a little longer. Because the Manhattan Project Uranium Chemist is not just a story about physics. It is a story about how organisms manage hostile environments. A lab is hostile in a controlled way. A body is hostile in a controlled way. and both survive by filters, barriers, and constant quiet work. So you shrink down again, and you become something smaller than a red blood cell. You become a single cell lining a kidney tubule, a tubular epithelial cell sitting in warm flow, doing dull labor. You are surrounded by filtrate, the fluid that will become urine if it is not reclaimed. Your job is reclaiming. You pull sodium back into the body. Water follows. You pull glucose back so it is not wasted. You secrete acids and drugs. You are a customs agent, stamping molecules in and out. And you are vulnerable because you are where concentration happens. If a toxin is in the blood, it may become more concentrated in the kidney. That is why heavy metals and certain compounds hurt kidneys. They meet you again and again in higher and higher local doses. Uranyl ions, for example, can bind to proteins and disrupt their work. They can damage mitochondria, reducing energy. They can trigger oxidative stress, reactive molecules that chew on membranes and DNA. In human terms, your factory line gets jammed, and then it gets set on fire. So the body has defenses, antioxidant systems, glutathione, a small molecule that helps neutralize reactive species, enzymes like catalase and superoxide dismutase, which sound like spells, but are just cleanup crews. You are constantly cleaning up little chemical messes, and most of the time you win. But if exposure is too high or too long, you lose. Cells die, tubules fail, kidney function drops, and then the organism, the whole warm animal, starts to drown in its own waste. That is the brutal truth. Life is a filtration problem. If the filters fail, the whole system becomes poison. And it does not take malice, just physics. Now, a softer thought still inside the body. You are made of atoms that are quietly unstable sometimes. Potassium-40 is in you, carbon-14 is in you. Tiny decays rare enough to ignore moment to moment. But your DNA still takes little hits. A strand break here, a base altered there, and every night, your cells do repair like a janitorial crew in a museum. They scan for mismatches. They excise damaged bases. They stitch strands back together. It is careful. It is constant. It is invisible. So when you think about radiation exposure in that lab, remember this. Radiation is not an alien force. It is an exaggeration of a normal background hazard. The difference is dose and location and how often. And your fear of it is not irrational. It is your nervous system trying to care about something it cannot sense. Humans are not built to feel ionization. We are built to feel teeth and fire and falling. So we build instruments and rules and rituals. We build artificial senses. That is what the Geiger counter is. An extra ear for the universe. Now let your imagination drift to the immune system again, because it is the body's version of a security program. It is also the body's version of secrecy. Your immune system does not announce most of what it does. It acts quietly, locally. A macrophage eats a bacterium in your lung, and you never know. A T cell recognizes a strange protein on a cell and triggers apoptosis, and you never know. There are tiny victories in you every day that do not get headlines. And sometimes There are tiny failures that also do not get headlines. A virus slips through. A mutated cell divides once, twice. A small colony forms, and the immune system might catch it later, or might not. That is the probabilistic nature of living tissue. So you can see the parallel to the lab. The lab tries to catch contamination early. Swabs, wipe tests, survey meters. The body tries to catch mutations early. Repair enzymes, checkpoints, immune patrols. Neither system is perfect. Both rely on layering. Both assume failure will happen sometimes, and they plan around it. That is a grim kind of comfort. It means you are not fragile because you are flawed. You are resilient because you are flawed in a managed way. Now, let's step back toward the human scale again, without leaving the quiet tone. Imagine a chemist years later, long after the war, sitting in a doctor's office. The doctor asks about occupational exposures. The chemist hesitates because secrecy is a habit that outlives its purpose. Then, finally, the chemist lists chemicals, acids, solvents, heavy metals, dusts. The doctor writes it down because writing is how humans pretend they can manage fate. And this is where the story gets messy, because teasing out cause and effect in health is hard. Cancer can have many contributing factors. Smoking was common. Solvent exposures were common. Radiation monitoring was imperfect early on. Records could be incomplete. So history becomes a set of partial logbooks, just like your lab notebook, but worse. And yet, what did come out of those years besides the obvious? Health physics as a field matured. Radiation protection standards evolved. Dosimetry improved. Ventilation design got better. The idea of keeping exposures as low as reasonably achievable became a guiding principle. In human terms, people slowly admitted that invisible hazards require humility, not heroism. Humility and paperwork and boring engineering. And that is the part that tends to be forgotten. The Manhattan Project is often told as a story of genius, but for many workers, it was a story of industrial hygiene, airflow, filters, protective clothing, decontamination protocols. The science was not always a chalkboard. It was a mop, a hood, and a measured wipe. Even the concept of a controlled area, the idea that contamination can be tracked by zones, became a template. Hot zones, warm zones, clean zones, different rules, different clothing, different waste streams. The goal is to keep the problem from migrating, because migration is what particles do. Migration is what humans do too. So the rules had to account for tired legs walking home, for sleeves brushing chairs, for shoes carrying dust, for laundry, for the fact that you cannot simply stop being a mammal. You sweat, you shed skin, you breathe, you rub your eyes when you are exhausted. So the system tries to catch you gently before you catch yourself in trouble. And sometimes it works, and sometimes it does not. Now the story meanders into another kind of chemistry that was everywhere in that era and rarely mentioned in the heroic summaries. Solvent extraction. The idea is simple. Some compounds prefer to dissolve in water. Some prefer to dissolve in an organic solvent. If you choose the right conditions, you can move a metal from one liquid phase to another. In human terms, you convince a molecule to choose one room over the other. You mix, you shake, you let the phases separate. Two layers form, like oil and vinegar. One layer holds more of what you want. The other holds more of what you do not. Then you drain one layer off. You repeat, because repetition is how you get purity. This method became important later for nuclear fuel reprocessing and separations. Even in the Manhattan era, variations existed for different metals, and it comes with its own sensory world. Organic solvents have smells that climb into your nose and stay there. Some are sweet, some are sharp, some make your head feel light, which is your brain politely informing you it is being poisoned. Fume hoods help, but they are not perfect. So you learn to read your own subtle symptoms, even while knowing symptoms are not instruments. A slight dizziness, a dry throat, a headache that arrives fast. You step back, you breathe cleaner air. You make a note, even if no one asked for it, because notes are how systems improve. And still, the work continues, because work always continues. One batch after another, one sample after another. The chemistry never runs out of ways to be tedious. And the tedium is, in a strange way, protective. Tedium keeps you from romanticizing what you are doing. It keeps you grounded in glass and stains and waste containers. It keeps you aware that the universe is not performing for you. It is simply behaving. Uranium behaves the way uranium behaves. Acid behaves the way acid behaves. Bodies behave the way bodies behave. And you are just trying to thread a path through all that behavior without getting hurt. Now, let your imagination settle on a small, quiet object again. A film badge, a rectangle of material pinned to a coat. Inside is film and maybe filters of different materials. The filters help indicate radiation energy and type by changing how much exposure reaches the film. Later, the film is developed. Darkening is measured. Dose is estimated.